This example comes out of section 9.2, Analyzing Rational Functions. In this particular example, we're asked to graph y equals x squared minus x minus 2 over x minus 2. Just to get a picture of it, graph it on your calculator, and you'll see a picture that looks something roughly like this. And you get your window settings right and everything, and it just looks like a straight line, which is somewhat surprising to somebody who has been playing with rational functions, and most of our rational functions have looked something like this, with asymptotes, vertical and horizontal asymptotes, and all kinds of weird and wonderful things going on. So the fact that this one gives you what looks like a straight line seems kind of strange. Now, if you look closer, you actually will find that there's a point here that doesn't exist on this graph. And to do that, let's look closer at this function. Y equals x squared minus x minus 2 over x minus 2. If the numerator there looks like a grade 10 factoring problem, that's because it really is. Two numbers multiplied together to give me negative 2 and add together to give me minus 1. And you have x minus 2 times x plus 1. And you'll notice that one of these factors is common top and bottom. So it is tempting to just cross those out, and we can do that as long as we remind ourselves that we do have a non-permissible value, that x can't equal positive 2. If you put in positive 2 here, you've got a problem because you're dividing by 0. If we do now cancel out the factors, we basically have a graph that looks exactly like y equals x plus 1, with one small difference, and that is that at x equals 2, there actually is a hole in this graph. Hard to see on the TI calculators. You have to either really zoom in, or if you look in your table of values and you look under the XY table, you'll see 0, 1, 1, 2, and then 2. Beside the 2, it'll say error, and you have an undefined value there, and then 3, 4, and everything else continues as normal. So this graph of this rational function actually turns out to be a straight line, except for it has what's called a point of discontinuity. Point of discontinuity. Now, English teachers might be more creative, but math teachers, we just name things for what they are as much as we can. So this is a point where the graph is not continuous. You have to lift your pen or pencil to put it back down and avoid that point of discontinuity. Now, if we're wondering where exactly that point is, the easiest way to do that is to take the value x equals 2, put it into this new function that we got down here, and realize that y would have to equal 3. That point happens at 2, 3. Now, that is not a point on the actual graph. It's actually the location where there's a hole in the graph. But so this idea of a point of discontinuity is new and weird and wonderful for us when we're used to doing vertical asymptotes at most of our non-permissible values. So what we've discovered is there's something else that can happen when you have a non-permissible value.